Hello again, Internet viewers, and today we are going to be doing another episode in the series of this wheeled robotics project. So in the previous video, I went over some designs and a frame which I wanted to use for this robot. But since then, I have taken the time to make a new frame out of several pieces of aluminum which I found. This frame is made of aluminum, so it is very lightweight and easy to drill into, which allows me to have many holes in the metal for mounting motors. And you can see we can accept up to 4 motors. And here's a motor right here. All these motors are cordless drill motors, and they come from cordless drills from Harbor Freight Tools, such as this one. Actually, exactly like this one. And basically, I took them apart so we could only get the motor. And this is just the motor that's inside of every single one of those drills. And it is basically a large DC motor, which is brushed motor, and that is connected to a gearbox. This is a planetary gearbox. It's not a very strong gearbox. It does have plastic gears, but it should work fine enough for this project. And of course, it has a shaft right here. This shaft is a 3/8 of an inch threaded rod, and it is a fine thread. And this is used to mount the chuck to the drill. And of course, on the inside of this shaft, there is another hole, and this hole is to accept a left-hand threaded screw which tightens down the chuck of the drill. But this is not a drill, so we have to find a way to connect a wheel to this motor. And I have purchased a couple of wheels from Harbor Freight Tools as well. They are lawnmower wheels, basically. Yes, so they are 6-inch lawnmower wheels, you can see here. They are solid wheels, and they have a 1/2 inch diameter hole in the center, so you can mount them to a lawnmower. But we have to mount them to this drill motor. So what I was thinking about doing was using these little adapters right here. You could see one near in the box. They're basically steel spacers which can take a 3/8 inch rod, like the shaft of the motor, and convert it to a 1/2 inch rod, such as the wheel. And you can see this does fit just fine. It doesn't wobble around a lot, but there's really nothing attaching it so it moves with the motor. It just spins freely. Of course, we could secure it using JB Weld, and I have thought about that, but of course that would be permanent and then we wouldn't be able to take the motor off. Another solution I was thinking about was using this design, which is not a steel spacer. It is actually just a piece of aluminum rod, and you could see I drilled into it along with the wheel, and then I put a screw here so the screw can stay in place and the motor will be able to move the wheel along with the screw. But a problem with this is that it doesn't fit as well under the shaft of the motor. You can see it does wobble around a little bit more. So I will have to find a better way to mount the wheels to the motors, but I think this is good for now. This frame of this robot was specifically designed in the same dimensions as the other frame, being 1 foot by 15 inches, but I put a little bit more thought into how the motors would mount, and that is very important for this project because we are using drill motors. They don't have a very, I guess, easy way for them to mount. So you have several options of how you can mount them. You could mount them by the can of the motor, which is easy to mount to. You could use these things right here. They are just simple electrical conduit straps. They're 1 1/4 inch EMT straps, and that secures the shaft of the motor housing down just fine. But it doesn't actually work very well because when this motor was in the drill, most of the load is not on the shaft of the motor right here. Most of the load is actually on a bearing, which is towards the chuck of the drill. That bearing is right here, and that is also secured in place with this design. So in this design, I can secure both the can of the motor shaft and the bearing of the gearbox to the frame. And you can see it doesn't move at all. And this is pretty hard to do. I think this is a pretty good way to do it. Just another thing is that you could see I have 2 pieces of aluminum here. I have one here and one at the bottom. This one at the bottom is simply used as a spacer so that the bearing is in line with the can of the motor when I tighten down the bolts which secure it in place. Of course, I need to take apart more of these drills, and that will allow me to put motors on all of these 4 corners in the areas. In the middle here, I think is where I'm going to mount electronics. This robot will not have very complicated electronics. I was thinking more like a couple of motor controllers. This is a cutting board, and you could find these everywhere. I got these at Walmart for $1 a piece. This is a very good, I guess, source of HDP sheets. So it's a flat sheet of plastic which you could work with and mount to. I'm thinking about just cutting it and putting it in the middle right here. And we could mount motor controllers to that. I was thinking about making H-bridges. Specifically, I was thinking about using these relays. I don't know if they would work. They can take 1 amp, which I don't know if these draw that. They probably draw more. I need to check that out. But that would be the idea. If not, of course, I could use MOSFETs or these relays of my own design. You could see these would definitely handle the current, but of course the coils would be hard to actuate even with but these coils of course would be hard to actuate just on themselves. They might actually draw quite a bit of power just to move these coils, but at least that would make it so I could have an H-bridge, so I would only have to turn on one of these to switch the direction of the motor. Of course, using MOSFETs would be better. I'm just thinking about more creative ideas to make something more interesting, I guess. And that would be how that would work. So this is my robot as of now. Pretty soon, I really need to find a way to mount these wheels to the shafts of the motor. And that'll probably be the next video on this project. Also, look out for a video I'm probably going to do about how to take apart these drills. There are many other people who use these drill motors for combat robotics, which, by the way, this is not a combat robot. It is a wheeled robotic platform, as the title describes. so it doesn't have to undergo as much stress as a combat robot would. But we could still use these drill motors, and that would actually be excellent for this project. So I will be making another video about how to extract the motors from these drills and convert them into motors which we could use for this specific project. And that is all for this video for today. See you in the next update.